Okay, in this lesson, we shall be focusing on Euclidean geometry. And it is without any exception that we shall actually be focusing things first, on this question. We want to calculate the size of the angle KMA. Right, here is K and here is M and here is A. And we're interested in finding the size of this angle here. Who can tell me the size of that angle there? Anyone quickly? We're able to see that in the part A, right, in the part A, so we have that the angle KMA, which is an angle at center, is actually 2 times 38 degrees, and 2 times 38 degrees equals 76 degrees. So, and the reason for that is that the angle at center equals 2 times angle at circumference. Okay. And now it means therefore this angle that is, we're talking about the angle KMA is actually an angle of 76 degrees. The next angle is the angle T2. Right, what is the size of this angle T2? Who can guess the size of the angle T2 here? We know very well that if there is a circle like this, and there is an extension, a chord that extends to one side, and it is forming such a quad like this, then this angle that sits here is equals to the angle that sits there. The exterior angle of a cyclic quad equals the interior opposite angle. That's what we say. So we say that the exterior angle of cyclic quad equals the interior opposite angle. So that in the end, then, we're interested in the angle T2, and this quad here can be seen to go like this and to go this way, and it goes this. So we have 4 vertices, and it goes furthermore like this. So that this angle here equals that angle there, as this theorem says, and therefore the angle T2, right, the angle T2 is clearly equal to the angle B, which is 38 degrees. Why? Right, so, and the reason for that is exterior angle of cyclic quad BKTA. The exterior angle of cyclic quad BKTA. So in other words, what is the size of the angle T2? It is exactly 38 degrees. And this one we have already found. KMA is actually 76 degrees. We proceed now. We want the angle C. What is the size of the angle C? Let's check. We are interested in finding the size of this angle here. What is the size of the angle C? Anyone? What is the size of the angle C? Anyone? Right, so that at this point, we're able to see that there is an angle, there is a shape like this. There is a shape like this. So that this angle here must be equal to this angle there, and this angle here equals this angle here. Right, so that in C, then we're able to see that the angle C is equal to what? The angle C equals this angle there. It's like a bow tie. So the angle C equals 38 degrees. Why? These are actually angles in same sag. These are angles in same segment. And this means that we have been able to find the angles like KMA, we found it to be 76 degrees. The angle T2, we found it to be 38 degrees. The angle C, we found it to be as well 38 degrees. So this one, we found it to be 38 degrees. The angle T2, this one here, we found it to be 38 degrees, to be actually equal to the angle B, and the angle T2 is 38 degrees. The angle KMA, this one here, we found it to be 76 degrees. Okay. We want angle K4. We want this one now. So we proceed to investigate that one. What is the angle K4? This angle here. Who can be in a position to find that angle there? Angle K4. Right. Anyone? Anyone? Okay. So you're able to remember that if you have a shape like this and you have a cyclic chord like this, and this angle equals that angle. Okay. This is the theorem. The exterior angle of a cyclic quad equals the interior opposite angle. So we were interested in finding the angle K4. We're interested in finding the angle K4. So now, if we're interested in finding the angle K4, the question is, what is the angle K4? What is it? Right, we've already found some of the things at this point. And if you look at the fact that this angle here, what is the size of that angle there? Right, but also we remember from this that NA is equal to NC. Right, so in other words, this side here NA is equal to NC. And we already know that this one is 38 degrees. So this is like an isosceles triangle. So if this side equals this side, then even the base angles are equal to each other. Their base angles are equal to each other. Right, so that now to do the K4 part of it, so we're doing part D now. We are able to see first that the angle NAC, okay, the angle NAC is equal to 38 degrees. The angle NAC is 38 degrees. Why is it 38 degrees? It is 38 degrees because you have angles opposite equal sides. We have angles opposite equal sides. Now, this is 38 degrees. Next, we then have that the angle K4, because of this, so you can see that this particular shape here, this particular shape here, this particular shape there. Okay, so you have something like this. So this angle, you need to look for an angle that is like this. Okay, so you have this here, and the angle now is this one. So that in the end, then angle K4 is equal to 38 degrees. And then you have the exterior angle of cyclic quad, exterior angle of cyclic quad, CKTA. This is the exterior angle of a cyclic quad, CKTA. Right. So in other words, now this here is, we've seen that this angle is 38 degrees, the K4. We have found angle C to be also 38 degrees. We found angle KMA to be 76 degrees. We have found the angle K2 to be equal to, rather T2, the angle T2 to be equal to 38 degrees as well. Okay, so we have done a fair, reasonable amount of work, but we want to right now do 10.2.2 to show that NK, right, to show that NK is equal to NT. We already know that K4 is 38 degrees. So now, if it is 38 degrees, it remains to just show that this part here is this angle T2. What is angle T2? We already got it. We've already got T2. It's also 38 degrees. So if you have 38, 38, so this angle here is equal to this angle there. Okay, so if these angles are equal to each other, you then have an isosceles triangle. You then have an isosceles triangle. So now to do 10.2.2, right, so we're looking at 10.2.2. To look at that one, we're going to work in triangle NKT, which means that angle K4 is equals to angle T2. Why? Because these are both equal to 38 degrees in 10.2.1. We've already shown that this angle here is 28 degrees. It is 38 degrees. And we've shown that this here is also 38 degrees. So you have 38, 38 degrees, so that these sides of this triangle here are equal to each other. So you have two, this triangle is called isosceles. So you are dealing with an isosceles triangle. Right, so that the angle K4 equals the angle T2, and they're both equal to 38 degrees. Okay, now because of this, we then say hence. Right, we then say hence, the side NK of the triangle is equal to the side NT of the triangle. Why are these the case? Because these are sides opposite equal angles. Sides opposite equal angles. Right, so yeah, just take a look at that one. So we've been able to do this one here and this one there, this and this, and we've been able to show that. It remains to just do the last bit, 10.2.3. We need to prove that AMKN is a cyclic quadrilateral just for 3 marks. Let's check that one. So we want to look at 10.2.3. And we want to prove that. We want to prove that A, M, K. Okay, because we're saying A, M, K, then N is a cyclic quadrilateral. Right, so Want to prove that this is a cyclic quadrilateral because these are 1, 2, 3, 4 vertices, and quadrilaterals are 4 vertex shapes. So they are shapes with 4 vertices, and we want to prove that this is a cyclic quadrilateral, and we proceed to establish the proof. Right, so now who can justify what is the reason? Why is that a cyclic quadrilateral, for example? What is the reason for that? Anyone? Anyone? I hope people are not sleeping. Anyone home? Why is this? These are 4 vertices. 1, 2, 3, 4. Why is it that it's a cyclic quad? This because cyclic quad means it satisfies the properties of opposite angles, supplementary, and so on. But if you look at a quad like this, right, it's cyclic because the vertices lie on the circumference of a circle, and therefore it is called a cyclic. It is called a cyclic quadrilateral. Okay, now let us continue here and see what we can do to establish some results. And let us continue. Let us continue. Right, so the couple of things that we need to learn, but you already know that this angle here, we did it before, KMA, we already know that this angle is 76 degrees, so that this one here is actually 76 degrees. Right, so we continue to analyze. Now, this angle here, we already know that it is 38 degrees. And this angle here, we already know that it is exactly 38 degrees. Okay, so now if this is the case, we analyze this and try to establish a result. For example, what can this one be if that is the case? So we start as follows to prove that A, M, K, N is a cyclic quadrilateral. We begin as follows. So we say that the angle KMA is equal to 2 into 38 degrees. And right, so we saw that it is 76 degrees there. And obviously that is angle at center. We did that before. Right, we proved it before and we established the result again. So the angle at center equals 2 times angle at circumference. Angle at center equals 2 times angle at circumference. Right, so now this one is 76, and then we do this one here. So we're gonna do this other angle, just this bottom angle N. We just want to find this one. So we're gonna then say the angle N is equal to what? This angle N is equal to 180 degrees minus 2 times 38 degrees. And now, what is then the size of this angle there? It is 180 minus 76, which is 104 degrees. And the reason is that you have the sum of angles, right? The sum of angles of triangle NKT. The sum of angles of triangle NKT. Right, so in the end then you have the following. Right, so Now, you then have that this angle here is 104 degrees. Now you then have that the angle, the angle KMA plus the angle N is equal to 180 degrees. If you add these two, it's equal to 180 degrees. So that AMKN is a cyclic. It's a cyclic quad. Right, it's a cyclic quadrilateral. Okay, because we've already shown that the opposite angles, this one added with that one there, is these two angles are supplementary angles. So since these two angles are supplementary angles, then we have that the shape AMKN is a cyclic quad. Next, we continue now to think about the next question, because we've been able to establish that this AMKN is a cyclic quadrilateral. But also we have been able to, find some of the angles, but like all of them, because T2, we found it to be exactly 38 degrees. The angle C, we found it to be 38 degrees. Also, the angle K4, we found it to be 38 degrees as well. And this one was proven, and this bottom one was done. So yeah, we are jubilant. We have been able to do much here. Next question. We need to complete this particular statement. Right, need to complete this particular statement here. Let us see what we can do. Complete the following statement so that it is valid. The angle between a chord and a tangent at the point of contact is what? Okay, who can complete this statement here? Anyone? The angle between a chord and a tangent at the point of contact. So in other words, we are dealing with this here. There is a circle, and then there is a tangent like this, a tangent with a circle. And we're interested in being in a position to ascertain the equality. For example, we have this. Okay, so the angle between a chord, because this angle here is between a chord and a tangent at the point of contact. The angle between a chord and a tangent at the point of contact, right, is what? Anyone? Right, so the angle between a tangent and a chord at the point of contact is equal. We're completing. Is equal to the angle subtended by the chord in the alternate segment, So that is what we have. So Now there's an angle here between a tangent and a chord. Also, you can have also here another angle. This one equals to this one. Okay, so you can make it like that, or you can make it look a little bit different. So you can remove this here, for example, remove this one here, and you can do this and then say, okay, now this is what you have. So this angle here is this angle here. So an angle between a tangent to the second and a chord equals the one in the alternate segment. Okay, so that's what we have. Next point. Right, the next thing is to look at this particular question. Let us solve this particular question. Right, there are a couple of questions. Maybe let us look at slightly nicer questions and slightly easier questions. For example, let's look at this one. What is this? Determine with reasons the value of x. How can you find the value of x? Because you have this angle here and that angle there. Anyone, what do we do to find the value of x here? Please talk to me. Please talk to me. Please talk to me. You're sleeping. Okay. At this point, we're going to see that to find the value of x, 3x plus 2x is equal to 180 degrees. Why? Because these are opposite angles. There are many questions I'm going to give you. Opposite angles of cyclic quad. Right, so once we say opposite angles of cyclic quad, we know that these opposite angles of cyclic quad are supplementary, okay? Their sum is 180 degrees. So that the sum then is exactly 5x equals 180 degrees, which means that 5x you divide by 5, which means 180 degrees you divide by 5, which means x is equal to what? Right, so you divide this by 5, and then now you're able to get the result. So what at this point is the result? So what is 180 degrees divided by 5? Okay, it is 36 degrees. So which means that x equals 36 degrees. And obviously, these questions that determine the value of x. And we have found that the value of x is 36 degrees. And because x is 36 degrees, we can do some of the calculations, which is 3 times right, which is 3 times 36 degrees. Okay, yeah. And then now we can do this one here, which is also 2 times 36 degrees. And this one is 72 degrees. Right, and then now you can do the other one. So if you do 36 by 2, it is 72 degrees. But if you do 36 by 3, you get 108. You get 108 degrees. So this one is 108 degrees. Right, so the angle A, for example, here would then become 108 degrees, and the angle C will then become like 72 degrees. Next question. Right, determine reasons the value of x. The value of x, and x is here. Who can find the value of x here quickly? Please talk to me. The value of x here. Who can find the answer? Right. Right. Okay. Okay, yeah, who can find the value of x? Talk to me, please. What is x here? What is the value of x here? What is the value of x here? Right, you're sleeping. What is x? X is this one. What is the size of the x? What is the size of the x? Senulu, what is the size of the x? What is the size of the x? You're sleeping.
Say is it 70 degrees?
How did you do it? Is it Tando? How did you do it, Tando? X, you know,
Is it
you're able to see the x. Yeah, okay.
is it exterior angle of a cyclic quadrilateral?
Yeah, yes, the exterior angle of cyclic quadrilateral. Okay, we are able to see that angle R2. The angle R2 is equal to 70 degrees. Why? Because of the exterior angle of cyclic quad equals interior opposite angle. So which means that this angle is 70 degrees. Then what is x? Then what is x? Because we know that this angle R2 is 70 degrees. Then what is x? Senulo, what is x? Senulo, what is x? Where is Senulo? Yes, Tando, what is x? Is it too easy? No, I'm giving you questions that are too obvious. I'm giving you questions that are too obvious. You don't want obvious things. You want difficult things. Now you are thinking this guy is giving us questions that are just a walk in the park. We don't want questions that are just a walk in the park. We want difficult things. Is that what is happening here? Okay, because this side equals this side, so it means that this angle is also x. So in other words, we note that the angle S2 is equal to the angle T is equal to x. The reason is that angles opposite equal sides. Right, so, or you can say that SR is equal to TR. This was given. Right. So that 2x plus 70 is 180 degrees. Right, 2x, so we're adding everything here. X plus 70 equals 180 degrees because you have the sum of interior angles of triangle, which means that 2x is 180 degrees minus 70, which is 110 degrees. which is means that 2x is 110 degrees. You divide by 2 like this, which means that x is 55 degrees. So x is 55 degrees, right? So now you need to understand that x is equal to 55 degrees. So, and we have that x equals to 55 degrees. And we're able to see exactly that, okay? So we continue right now and we solve more problems. We solve more and more problems. Just look at the next question. Right, in this question, we have that O is the center of the circle, X is 40 degrees. So X here equals 40 degrees. If X is 40 degrees, determine with reasons the size of the angle Q1, the angle B, and the angle A. Let us find the angle Q1 first. Let us find the angle Q1 first. What is the size of the angle Q1 here? Anyone? The size of the angle Q1. Okay. Want to find the size of this angle Q1. Okay, what is Q1? Anyone quickly?
So is it equal to 40 degrees?
Is it equal to 40 degrees? Well,
What?
please come again.
40.
40 like 40, right? Like 40. Okay. Right. So it is just close to that, but it's not exactly 40 degrees. It is something else. Okay. Now there is, because this one is a diameter and because O is the center. O is the what? O is the center. So if O is the center, then it means that this line, what do you call this line here? PQ. What do you call the line PQ? What do you call the line PQ? What do we call the line PQ? You forgot. Did you forget line PQ and what the line PQ is called? Right, okay, because if this one is passes through the center, it is called a diameter. This line is called a what? A diameter. So a diameter in mathematics subtends an angle of 90 degrees at the circumference of the circle. And that means that the angle R1 is equal to 90 degrees. The angle R1 is equal to 90 degrees, and the reason is that angle in semicircle. Angle in semicircle. So now, if this is an angle in semicircle, what do we then get? So this is 90 degrees. So now the angles now in the triangle. So you have that in triangle PRQ. Right, triangle PRQ, we're able to see that 40 degrees plus 90 degrees plus Q1 is 180 degrees. And this is the sum of interior angles of triangle. What is 40 plus 90?
130.
130. So we have that the angle Q1 is equal to 180 degrees minus 130. What is 180 minus 130?
50, sir.
It's exactly 50 degrees. Well done. So yeah, that is exactly 50 degrees. Okay, I'm excited. That is 50 degrees. And now the examiner just wanted the size of the angle Q1. So the angle Q1 is 50 degrees. So 40 plus 50 is what? What is 40 plus 50?
It's 90.
And now, so these two, and you add them, we get 90. And then 90 plus 90 is what?
180.
180. So these angles in this triangle add up to 180 degrees. Next question. The next question is we need to find the size of angle B. This angle here. We already know what x is. What to get x to be? Because we already know this one is 90 degrees. We already know that this one here is x is 40 degrees. You already know that this one is 50 degrees. What is the size of the angle B? Anyone? Because they want the size of angle B. What is the size of the angle B? What is the size? What is it? What is it? Okay, anyone? Anyone? Right. Mm-hmm. What is the size of the angle B? Anyone? You're not sure? Okay, now look. If you have a shape like this angle plus this angle, if you add them up, the sum is 100 and what? And 80 degrees. Tsenulo, where are you? Are you sleeping, Tsenulo? Are you sleeping, Tsenulo? Want the size of the angle B. What is the size of the angle B? What is the size of the angle B?
140.
Well done. Okay, so we're able to see that the angle B, in other words, we're able to see that 40 degrees plus the angle B must be 180 degrees. So 40 degrees plus angle B is 180 degrees. These are the opposite angles of cyclic quad. Opposite angles of cyclic quad. Which means that angle B is equal to 180 degrees minus 40. What is 180 degrees minus 40? It is 140 degrees. So this one here is 140 degrees. So the angle B equals 140 degrees. Next question. The next question is to find the size of the angle A. This one. What is the size of the angle A? Let us check that part. Right, we've already found some things like this one, this angle X is 40. This one, we found it to be exactly 50. This one is 90 degrees. Angle B is 140 degrees. What is the size of the angle A? This one here. What is the size of the angle A? What is it?
Is it 130, sir?
130. Well done. Because now, obviously, these are the four vertices. So you are dealing with the cyclic quad, and this angle plus that angle must be equal because you have 1, 2, 3, 4 vertices. So in other words, you're gonna say that 50 degrees plus the angle A must be equal to 180 degrees because these are the opposite angles of cyclic quad. These are the opposite angles of cyclic quad. PARQ, which means that angle A is equal to 180 degrees minus 50. What is 180 degrees minus 50? What is 180 degrees minus 50? What is the size? 180 minus 50 is what?
130.
130. So this is 130 degrees. It is exactly 130 degrees. That is the size of the angle A over there. Size of the angle A over there. 130 degrees. Okay, so we continue to solve more problems. Next question. Here, M, P, S, and T are points on a circle with center O. Right, so you have M, P, this is M, P, S, and T are points on a circle with center O. PT is the diameter. PT is the diameter. In other words, it is a straight line. It is a chord that passes through the center of the circle. MP, MT, MS, and OS are drawn. Angle M1 is 53 degrees. You can see it here. It is 53 degrees. Is M1 over here. Determine with the reasons the size of the angle O2. We want the size of O2. What is the size of O2? Anyone? Senulo, what is the size of O2? Senulo, what is the size of the angle O2 in the diagram? What is the size of the angle O2 in the diagram? Senulo, yes, what do you think?
I think it's 106.
You think it's 106 degrees. Why would it be 106 degrees there? Tando.
Say it is 2 times the angle at circumference.
Okay. Right. It's very interesting because now you are dealing with the angle O1, which is this one here. And then you're dealing with O2, which is this one there. So how did you do it? What are the steps? Okay, now remember that when you have a shape like this, if this is A, O, B, C, then you say A, O, B is equal to twice angle C, and we say angle at center. Angle at center equals 2 times angle at circumference. Okay, angle at center equals 2 times angle at circumference. And therefore, we have the following, that the angle O1, the angle O1 is equal to 2 times 53 degrees. Angle at center. Right, angle at center. Right, at this point, then we have angle at center equals 2 times angle at, 2 times angle at circumference. Okay, so the angle O1 is then 2 times 53 is what? 106. Right, so this angle here is 106 degrees. But these are on a straight line, these. So we have that angle O1 plus angle O2 must be 180 degrees. Which means
Adjacent.
yes,
Yeah.
definitely. These are adjacent. Well done for the reason adjacent angles on a straight line. So yeah, and this is plus O2 equals 180 degrees. What is this? What is angle O2? 180 minus 106. What is 180 minus 106? 74 degrees. So this one can only be 74 degrees. Okay. Any question? Any question there? No question. Right. So in the absence of a question, we move on to more things. Move on to more questions. Right here, AB equals BC. We have that AB is equal to BC. Right, AB equals BC, and that's what we are able to establish out of this. So AB equals BC. Okay, AB and BC are equal. Angle ABC is 50. Angle ABC is how many degrees? 50 degrees. Calculate with reasons the sizes of angle F. This one. What is the size of angle F? Anyone? Senulo? Anyone? Senulo? Right. What is the size of the angle F? This one. We're interested in finding the size of the angle F. What is the size of the angle F? What is it? What is the size of the angle F? Anyone? Tando, what do you think the size of the angle F is? What is the size of the angle F? Is it too easy? Is it too easy or too difficult?
At 25 degrees.
25 degrees. Okay, that makes lots of. Okay, you're close to the answer. But obviously, because we know that this angle here is equal to this angle there. So we can let the angle A2 be equal to X. And thus the angle A2 is equal to the angle C equals X. So this is X and that is X. Why is the angle A2 equals the angle C? Well, the reason for that is that you have AB equals BC. This one, AB equals BC. So you have AB equals BC. And this is true because these are given that way, all right? So obviously at this point, then you have 2x plus 50 degrees is equal to 180 degrees. And this means that you have the sum of angles of triangle ABC. Right, so which means that 2x equals, what is 180 minus 50? 130. Okay, you can write some steps here. You can write and say we have 180 degrees minus 50 degrees. And we have 2x. What is 180 minus 50? It is 130. We have 2x divided by 2, which is 130 divided by 2. What is 130 divided by 2? What is 130 divided by 2? 65 degrees. Right, so that now we can see that this angle here is 65 degrees. And this one is also 65 degrees. So what is the angle? So now you have the angles in the thing, in the bow tie. So this angle here is equal to this angle there. So the angle F is equal to angle C, which is equal to 65 degrees. Why is this the case? This is the case because so these are angles in same segment. Angles in same segment. Angles in same segment. Angles in same segment. So in other words, this one is also 65 degrees. As much as this also is 65 degrees. What is the size of the angle D? What is the size of the angle D? Now we're interested in the size of this angle here, so let us look at that one. So we've already seen that this angle is 65 degrees over here, and this is also 65 degrees there. What is the size of the angle D? Anyone? If this ABC is 50 degrees. Right, let me see you to ask. Sedulo, what is the answer? What is the answer? Okay, yeah, we're interested in finding the size of the angle.
Okay.
Yeah.
I
What do you
say
think?
the answer is 115.
115. Why is it 115? So first we shall see that 65 degrees plus the angle D. 65 degrees plus angle D is 180 degrees, which means these are opposite angles of cyclic quad. These are opposite angles of cyclic quad. Right, of cyclic quad. A, D, B, C. Right, which means angle D is 180 degrees minus 65 degrees. Means that angle D is equal to what? Right, you subtract this here, and if you subtract what is this? It is 115 degrees, right? It is 115 degrees. Right, so in other words, we have that this is 115 degrees. So now in the end, then you have that. Okay, we found that the angle F is 65 degrees. And the angle D is equal to 115 degrees. Right, and these are the two answers to these particular questions. Any question about this? No question about this. So we're going to give you homework. Right, here is your homework. In this homework, you're going to practice and find angle L1. You're going to find angle L1. You're going to find angle O1, this one. You're going to find angle M4. One. You're going to find angle N1 plus N2. Angle N1 plus N2, you're going to find that. You're going to prove that KG is equal to GM. You're going to prove that your KG equals GM. So if this is your K and this is your G, so KG equals GM. Right, so, and I didn't want to be very long. So my plan is to take 1 hour on most of the evenings. I'm gonna be inviting you to throughout the week to have these 1 hour discussions, okay? And so, yeah, we have had a discussion of approximately 1 hour, and this is your homework, and I'm gonna mark this tomorrow night. But if you are busy, you let me know. If you are busy with your homework, you are busy with something that night, you let me know. But I'll be available in the night for 1 hour for a couple of days every week. Okay. Right. Yeah, so I must thank you guys for joining us. I'm gonna mark this homework. This is a home activity. This is your home activity. I'm gonna mark it. I'm gonna mark it tomorrow. I'm gonna mark it tomorrow evening. Yeah, okay. Right, for now, we are done for today. Until tomorrow. Tomorrow, 4 p.m., I'm available, and tomorrow, 8 p.m., I'm available. If you're busy at 4, you join at 8, you know? Or you can do both 4 and 8, but I know some of you are busy at 4. So you don't join at 4 because you are busy, and then you join at 8. Are we together?
Yes, sir.
Right, yeah. Otherwise, for today, thank you for joining us. I will see you tomorrow at 4 and 8. Depends on when you are free. You join, and we continue doing more math and science. There's more science that's coming this week. Okay, there's more chemistry that is coming this week, so get ready. Okay. All right. There's more chemistry in particular for you, for the two of you guys, because you guys do chemistry and mathematics. So yeah, I'm gonna see you tomorrow to all right. But yeah, if you are busy tomorrow, it's okay. Then you can see me on Friday. But I'm saying this I'm gonna be popping in most of the time, every day. 4 and 8. You are busy at 4 and join me at 8. Every day I'm gonna be available online. Just for 1 hour to make sure that you have time to do other subjects as well. I don't want to burden you so much so that you break down and you start hating the subject, you see? I don't want that. All right. So thank you guys, and thanks a lot. I'm gonna be sending the video, and you're gonna be seeing this home activity on the video. Otherwise, thanks a lot for joining us this evening. Until tomorrow, have a good evening and good night.
Okay, good night.
Good night, guys. Good
Good
night.
night, sir.
Good night, guys.